Hello everyone and welcome to your maths lesson for this week. I just want to say a massive well done to everyone for all their My Maths work. There were some excellent scores on the multiplication and division tasks that you were set, and you will have been set some new My Maths tasks for this week. Also well done to everyone who has been keeping on with Times Zero Rockstars. I've seen some excellent speeds and scores, so keep it up guys. Today's maths lesson is all about line graphs, how to kind of use them and solve questions by looking at them. So let's have a little look. So for this week, our learning objective is to solve problems using line graphs. We are still focusing on this growth mindset. A lot of the problems are going to need some critical thinking and taking your time and reading through the problem to really get to a sensible answer. So to start off, we are going to do some arithmetic, and I'd like you to have a little go at this on your own, and then when you're ready we'll go through the answers. So pause the video now. Okay, let's look through some of the answers. So our first one, 8,956 divided by 6 should have been 1,492, remainder 4, or 1,492.66, depending on the context of the question. Next one, 801,821, take away 15,927. So if we use a column subtraction, you would have got 785,894. Our next one, 12% of 440, would have given you 52.8. So you could have done 10%, and that would have also helped you to find 1%, dividing by 10 or dividing by 100. Number 4, 360, take away 40 times 7. We're going to need to use BODMAS or BIDMAS. And your answer would have been 80. So you have 360, take away 280 equals 80. Number 5, 0.04 times 13 is very similar to 4 times 13, which would have given you 52, so 0.52. And our last one, this would have been some long multiplication. 1,782 times 24 would have given you 42,768. So well done for having a go at those. Right, I'd like you to have a little go at this reasoning question. Read through it, and then when you're ready, pause the video and have a little go. So, pause the video now. Okay, well done. So it says Amina's bed is 190 centimetres in length and 91 centimetres in width. She is making a 1/10 scale model of the bed. What are the length and width of Amina's model? So 1/10 would be one small piece if you split it into 10 pieces, so one of those pieces. So it's going to be a much smaller version of the bed. It's a model. So if you think about making a model, they're never the same size unless they're a 1-to-1 scale model. But this is 1/10. So we're going to need to divide by 10. So we're going to divide 190 by 10 and 91 by 10. So we should have come up with the length was 19 centimetres and the width was 9.1 centimetres. Okay, each of your digits would have moved to the right 1 decimal place. And for this one, we'd had to have your decimal point. Okay, well done for having a go at those. Okay, you're going to get a treat today. You're going to get to hear somebody else's voice, and we're going to have a little watch of a video explaining a bit more about line graphs and how you kind of make one and why you would make one, just to give you an example of when you would use one. So let's have a little listen.
There are many different types of graphs. All of them are used for different reasons, but all of them make information easier to read. A line graph is used to show how the quantity or amount of something changes over time. For example, I recorded how many apples I ate each month for 6 months. Here's my data in a tally chart. Remember, Data is the information you collect in an investigation. At the end of 6 months, I can add my data to a line graph to show how the number of apples I ate changed over time. After I add labels to the side and the bottom, I can begin to plot the data. When you plot, you put the data in the right spots on the graph, like this. Plot that point, and plot that point. There. And now each point on the graph shows the number of apples I ate that month. To make it a line graph, just connect each point in order, just like a dot-to-dot picture. This makes the data even easier to read. In this line graph, it is easy to see that I ate the greatest number of apples during the 3rd month, 10 apples, and I ate the same number of apples in the next 2 months. I know this because the line doesn't go up or down, it goes straight across. And in the final month, I ate the least number of apples, only 3. Look how many more I ate in this month than I did in this month. All we need to do now is add our title, Apple Time, and done. The perfect line graph.
Okay, so as the guy explained, that's how you kind of make a line graph and why you would make one. But here's just a bit more information about line graphs in general. So line graphs are used to show changes to a measurement over time. They show continuous data, so the data is always moving along. The data is being measured is shown on the vertical axis. Okay, so going up here. So that's what you're actually measuring. So this one, it's temperature. The time the data is being measured over is shown on the horizontal axis. So across here, this is the time one. So it could be days, could be months, could be hours, years, any measure of time. Data is then plotted onto the line graph, as was shown in the video, in the same way as you would do on a coordinate grid. So you go across how much time, and then up to wherever your data was. And then these are joined with straight lines. Okay, so you would need a ruler to join them. We can use the line of the graph to describe trends. So you can see it kind of going up or down or across in the change of the measurement over time, or to find a very precise measurement at a certain time. So what's the big picture today? Line graphs are an important way of presenting data. They can show something like the decline in a species population over time, or the amount of rainfall in a city over a year, as we can see in these two kind of line graphs here. Some of the key vocabulary for the lesson is data and the axis, so vertical, horizontal, plot and the points that you might plot, labeling, so labeling the axis, the information, so similar to the word data, and how it might change, the kind of trends that you'd have. Again, use your 4 Bs if you're going to get stuck, and we're still focusing on our growth mindset and how we keep going if we are stuck. So we're going to start with a my turn, and I'd like us to have a little look at this with me. I'll explain how we do this. So it says, Eva has created a graph to track the growth of a plant in her house. So she's going to see how much it grows over a certain period of time. And at the top here it says plant growth in July. And she's plotted every couple of days all the way to the end of the month. And she's put a date here. On this axis, how much she's measuring the height in centimetres. She's gone up in jumps of 5. Because her highest measurement over here is about 28. So she didn't want to go in ones, because it would be a very big scale then, wouldn't it? So it says, Eva recorded the following facts about the graph. A. On the 9th of July, the plant was about 9 centimetres tall. Okay, let's have a little look. That's and it says about 9 centimetres. So it's not far off. But it's actually closer, sort of halfway between. So I wouldn't say it's quite 9. So we have to come back to that one. Between the 11th and 19th of July, so between the 11th and the 19th, the plant grew about 5 centimetres. So the 11th is 10 and the 19th is 15. So that's a growth of 5. So she is absolutely spot on with this one. At the end of the month, the plant was twice as tall as it had been on the 13th. So I'm going to look at the end. So the end of this month is 31 days in July. And up here, it's just above halfway. So it's about 28 centimetres. If I came across to here. And on the 13th, it was actually around 10. So that's not half, is it? So to correct that, you want to be halfway, you want to be at 14, so you'd want to be somewhere around 17th here, so that's nearly 15. So let's have a little look and double check. So yeah, the more accurate measurement would have been 7.5 for this first one, on the 9th. Okay, 9 centimetres would have been a bit higher. B, we were correct, yeah, she was right. And C, yeah, on the 13th, it was only 10 centimetres, which is not half of 28. So to correct it, if it was to be 14, which is half of 28, it would have been about the 17th of July. So there, so past halfway. Okay, so if you can see that it actually started picking up growth here, it actually grew quicker as it got near the end of the month. Let's have a look at an hour turn. I'd like you to have a little look at these 3 line graphs. They don't have any labels, so it's up to you to think about what they could be showing. So I'd like you to write a story or write an explanation of what these line graphs could be showing. And see if you can write 3 questions for them if possible. You might only write a couple, that's fine. So pause the video and have a go now. Okay, well done. So let's have a little look at what you could have shown. There are loads of different answers for this. That's why this one's really interesting. So you could have had for A, possible one could have been a car speeding up. So its speed was going higher and higher as it was moving along in time. So it's getting faster. And then it went at a constant speed. So it carried on going at the same mile an hour. And then it was slowing down as maybe it got to its destination. So it could show the speed of a car during its journey. B could have had the height above sea level a person is at during a walk, because they went up a sort of hill and then they were going along it, and then they might come down and up, and then they kind of come back down to the finish where they started. And C, it starts all at the top here, so that's interesting. So it says the temperature in an oven when you are cooking something. So you would have warmed the oven up first before you put it in. So the temperature would have already been high, your measurement would have been high. And then it would have dropped down, maybe when you open the door or when you put it to the temperature you wanted. And then as you check the temperature here when you open the door, because all the heat will escape. And then when you finished, the temperature will drop off as the oven cools back down. So another little my turn. And we've got a graph here to show the distance that a car has travelled. On this side, it says distance travelled in miles, and along the bottom, it says time in minutes. But there's a bit missing. So Rosie and Jack were asked to complete the graph to show the car had stopped. Here are their completed graphs. So Rosie has joined the 2 dots in here with a straight line. Jack, however, has drawn a line down and then he's gone across and then back up. Who has completed the graph correctly? I'm just going to zoom in so you can see that a little bit better. So if we go down here, look. As we said, Rosie had drawn a straight line there, and Jack had gone down, across and up. Who has completed the graph correctly? Explain how you know. So, I'm going to help explain, because it says Rosie had completed the graph correctly because the car still travelled that amount of distance. All right, it hasn't like gone back. They're on their journey. So maybe she's just stopped for a little part and they'd still gone that distance. And then they carried on their journey, carried on moving. For Jack, if they'd gone back here, they'd have gone back. They'd have travelled nothing. Could have like almost gone back to the start. But they didn't, they just stopped. Didn't go back. So this one is incorrect. So Jack is incorrect. Okay, we've got another hour turn. And this one shows some of Mr. Woolley's journeys. It has distance of journey on the left and time of journey hours on the bottom. And there are 3 different coloured lines. Okay. So he's starting here, and as time goes along, that's how far he's going. So it says, what is the same and what is different about each of these journeys? What might have happened during the green journey? Because we can see it looks different, doesn't it? So something has changed here. These are all carrying on in a straight line, these two. But the green one has gone up and then gone up. So what could have happened? Think about a journey maybe in his car. What would have happened? So let's have a little peek at some of the ideas, possible ideas. All the journeys were nearly the same length of time. So our time here, the blue one, the red one, they're all similar sort of time. This one's slightly longer, but they're similar times. So that's a general kind of trend. The next one, the journeys were all different distances. So distance is how high up they've gone here. So the blue one's only got to here. The red one's a bit further along, and the green one's even further. So the green one, he's gone the furthest. The blue one has gone the least. The red and blue journey were travelling at constant speeds. So, because they kept going, all right? It wasn't going up and down, so fast and slow. But red was travelling quicker than blue, okay? Because it's a steeper line. He was getting to he's going further, faster. So he travelled further in less time. During the green journey, Mr. Woolley might have been stuck in traffic or stopped for a rest. So he actually sped off quite quickly in this one because it's very steep. Then he might have stopped. It could have been a traffic jam, an accident. He might have just stopped at the service station or to see someone. And that's the amount of time he did stop for. And then he started his journey again and he carried on. So that's how you kind of look at the trends in a graph. You need to look at the axis to see what it's telling you, but also the trends of the lines. They tell a story. So this is your turn. It says, what could this graph be showing? And we've got the axis with digits labelled, but no actual heading. So have a go at labelling both the horizontal, so this one across, this is always time, and the vertical, so what it's measuring, and you can make up what it shows. It says, is there more than one way to label the axis? Just to have a little think, okay? Have a little go at that now. Okay, so this is just one possible answer. There are many, many ones. So you could have had time in seconds down here. Could have been minutes or something else. And this one said height in meters because it was going. They've said it's going up. And this one is to show the time and height of drone flights. So they've tracked how high they've gone during the amount of time they're flying. So the red one started off a bit lower, and then he kind of went higher than the blue drone, and he stayed above him, and they both came down. So they're both kind of going up together maybe. But the blue one couldn't fly as high. There are lots of different answers for this, so well done if you had a go. It's really fun to kind of make up your own ideas for line graphs. So, steps to success for today. If you're answering questions using a line graph, so if you've already got the information, you just need to interpret it and look at it to answer the questions. You need to look carefully at each axis heading. So what is it telling you? So what is the scale of time? And also what is the measurement? Work out the scale, how much is going up by, because that gives you a clue of if you're looking in between the scales. can you see any patterns or trends? So like when we saw Mr. Woolley's journeys, you could see how his journeys were changing when he stopped, or you could see the speed of the journeys, but how steep the lines were. If you're drawing a line graph or having to fill in parts of a line graph, make sure you use a ruler if you're completing it. Choose an appropriate scale. So think about the kind of jumps that you need, what's going to work, and then label your axes with headings. So make sure they are clearly labeled so that someone else, if they see your line graph, can understand it and they can use it. So this is our LO for today and our chilies. So we're going to be solving problems using line graphs. Chili 1 is to complete a line graph, some fluency type questions and problems, and some sort of creating your own. Chili 2 is to solve a range of problems, including line graphs. Chili 3 is some multi-steps that some different parts to it and create possible answers. So a bit more creating your own. Same vocabulary as earlier. And let's have a little look at the chilies. There are lots of parts of the chilies today because there's part 1 and part 2 because there's the big sheets. And at the end of all the chilies, there is a page with some links to some extra bits of work or some other ideas that might help you. So don't forget to have a look right at the end of the video for that page. So I'm going to show you the chilies now, and you can pause and have a go at the ones you want to. So you have chili 1. We have chili 1 part 2. We have chili 2. Chili 2 part 2. Chili 3. And chili 3 part 2. And as I said, finally, there are some links here for some home learning packs, which could be really interesting, not just for this lesson, but also other lessons. I'm going to make it a bit bigger. There are some home learning packs. If you go to Hamilton Trust and Home Learning Packs, that website, there are loads and loads, and there are even some videos for you and parents as well. Also, if you go to BBC Bite Size, and if you go to the handling data topic in the Key Stage 2, there are lots of different types of data on there. So you can see bar charts and Venn diagrams and pie charts as well. And please don't forget to send your work in to our Year 6 email. So year6@franchprimary.works.sch.uk. Okay, I look forward to seeing all of your work, and good luck, guys.